Hi children, welcome to Vivi's Chemistry Talks. In the today's chemistry class, we are going to discuss about types of reactions, especially combination reactions. You have already learned about the different types of reactions. Which are the different types of reactions? Combination reactions, decomposition reactions, displacement reactions, double displacement reactions, redox reactions, neutralization reactions, etc. How will you identify one reaction from another one? Is it easy? Yes. So let's begin with combination reactions. Ready? Combination reactions are also known as synthesis because new products are synthesized. But how these reactions are different from other reactions? Very simple. In combination reactions, you will get only one product, a single product. If there are more than one product, then it is not a combination reaction. In every combination reaction, you will get a single product. So, we can define combination reactions as reactions in which two or more substances or reactants combine to form a single product. So, reactions in which two or more reactants, they combine to form a single product. In every chemical reactions, reactants react, combine to form products. But in combination reactions, only one product will be formed. So it can be generally represented as P plus Q giving PQ. P and Q can be any reactants. Let them be elements, let them be compounds, but we will get only a single product. So I will write down 2 or 3 reactions here, chemical equations of 2 or 3 reactions. Identify which one is a combination reaction. Okay? Now, examine these reactions carefully. Look at the first equation. This is ferric oxide. Ferric oxide plus aluminum giving aluminum oxide plus iron. Is this a combination reaction? How many products are found? 1, 2. There are 2 products. No, this is not a combination reaction. Now what about the second one? This is methane. Methane plus oxygen. This equation represents the combustion of methane. So methane plus oxygen giving carbon dioxide and water. Here also 2 products are found. This is also not a combination reaction. So these are not combination reactions. Now what about the last one? 2 Mg plus O2. There are 2 reactants giving 2 MgO. So how many products are formed here? Only one product. Since only one product is formed here, this can be considered as a combination reaction. I hope this is clear for you. Now let us examine more examples of combination reactions. First, we can consider some combination reactions in which 2 or more elements combine to form a single product. You are familiar with these reactions? Okay. First, we can take sodium metal and chlorine gas. So, how will you write the symbol? Please remember, sodium is a metal. Its symbol is Na. It's monoatomic. So, we need to write only the symbol. Then, sodium combining with the chlorine gas. Chlorine gas is diatomic. So, when we write the symbol of chlorine, we have to write Cl2. Chlorine molecule is diatomic. Now, what will you get? Predict the product. When sodium combines with the chlorine, you will get sodium chloride, our common salt. Please check whether the reaction is balanced to chlorine. One more example. Take another metal, that is magnesium. Magnesium combines with oxygen to form what? Magnesium oxide. Please recall how do we write the chemical formula of the compounds using their symbols and valency. Now, take another example. Here, instead of a metal and a non-metal, we are taking two non-metals. Hydrogen gas combining with oxygen gas to give water. This is a very important chemical reaction. Okay, so look here, children. In all these reactions, you can see only a single product is formed. That is why we call them combination reactions. Now, why don't we consider another combination reaction in which two compounds react with each other to form another compound? A classic example given in the NCERT textbook for combination reaction is the reaction of quicklime with water. It is stated as follows. Quicklime reacts with the water to form slaked lime, releasing a large amount of heat energy. Here only a single product is formed. But this is a special kind of reaction. It is because it has immense applications in our daily life. So what is quicklime? Do you have any idea? Quicklime is one of the chemicals, one of the oldest chemicals known to the human beings. Now, this reaction is a special reaction. It has a lot of applications in our daily life. Quicklime is a special chemical. It's a common chemical found in our surroundings. We can easily prepare it. Now, what is quicklime? It is one of the oldest chemicals known to human beings. Human beings started using it from the medieval period onwards. Its chemical name is calcium oxide. Remember, children, whenever you see a compound with having a name with the term lime, it is usually referred to compounds containing calcium or calcium compounds. Quicklime. This is a very special reaction because it has immense applications in our daily life. Quicklime is one of the oldest chemicals known to the human beings. From medieval period onwards, we are using it. And it is not that much difficult to prepare quicklime because the raw materials are already available in nature. Like seashells, clamshells, then limestone. So when you heat limestone or seashells or clamshells for a longer period of time, like probably 8 hours like that, Children, a classic example for a combination reaction given in the NCERT textbook is the reaction of quicklime with water. This process is known as slaking of lime. When we use the term lime, remember they are calcium compounds. Then, when we slake quicklime, we will get slaked lime. Now, what are the chemical names of slaked lime and quicklime? Quicklime is calcium oxide. And slaked lime is calcium hydroxide. Okay. Now, this is a special kind of reaction. Okay. That means this is very important for farmers, painters, then for preserving food items, etc. So, when we consider every chemical reaction as something related to our life, studying chemistry will be fun. So, understand the importance of chemical reactions in our daily life. Then it will be very easy to remember. Okay? So, what is special about this reaction? Calcium oxide is a base. Slaked lime, that is calcium hydroxide, is also a base. This reaction is preferred by the farmers in agriculture because it is very easy to prepare good quality slaked lime from quicklime using this method. All you have to do is simply add water to quicklime. But remember, the slaked lime that we obtain, the state of the slaked lime that we obtain depends upon the amount of water we add. If we add less amount of water, we will get slaked lime in the solid state. Now, if we add more amount of water, we will get slaked lime as an aqueous solution. Now, we need slaked lime in the solid state because it will be easy to mix it with the soil. So, farmers add very less amount of water in order to prepare slaked lime. So, quicklime is comparatively cheap. Okay, so it is a cheap chemical and you will get large amount of slaked lime if you are using this method. And the slaked lime prepared by this method is also used in the early days for preserving food, like preserving eggs. Now the Chinese people also prepare delightful Chinese tofu using the same chemical reactions. They use slaked lime. Okay, so understand the importance of this reaction. So it is fun. Chemistry is fun. Okay. Now let's watch a chemical reaction. And why don't we do this experiment? But I am not going to show this experiment in a chemistry lab. We are going to watch it in a natural laboratory where real people work. Okay? So let's watch this reaction, this combination reaction in which quicklime reacts with the water to give slaked lime. Ready? So children, come back to our natural laboratory. We are going to see the reaction between quicklime and water. Okay, so these are the reactions. This is quicklime. This is used by farmers to reduce the acidity of the soil. So you can understand its nature. This is basic. So quicklime is calcium oxide. Our next reactant is water, pure water. So these two are the reactants. So let's read the reaction between quicklime and water. Okay. So now children, we can see the combination reaction of quicklime with the water. Okay. So this is a natural chemical reaction. This reaction has been used by our ancestors to prepare slaked lime from quicklime. And you can see quicklime, this is prepared from seashells. See. Now let's see the changes when water is added to quicklime. I have also taken some quicklime in the bucket. I am going to add more water into the bucket. So let's see. Okay, I'm going to add some water here. Now I'm going to add water into the bucket also. Here I added more water. So let's see the difference. Now we can wait. Watch the changes carefully. Now children, you can see the reaction has started. See, water reacts vigorously with quicklime. You can see the shells now. These shells are getting powdered. The color of the reactants, that is quicklime, is changing into pure white color. Here when quicklime reacts with water, children, slaked lime is formed. Since I added less amount of water, the slaked lime is formed in the solid state itself. Now you can see the reaction is vigorous and we cannot touch it because a large amount of heat energy is released. You can see the fumes coming up. Now what's happening inside the bucket? There we added more water. You can see the reaction mixture boiling. No, the reaction is taking place. It is highly exothermic. A large amount of heat energy is released in this process. So this reaction is a combination reaction as well as an exothermic reaction. Now look at the mixture on the ground. Quicklime vigorously reacted with the water to form slaked lime. Now this slaked lime has a lot of applications. Farmers use this slaked lime in the solid form to mix with the soil so that the acidity of the soil can be reduced. If the acidity of the soil is too high, plants may not be able to absorb the nutrients present in the soil. So adding slaked lime to soil will reduce the acidity and plants will grow well. The reaction is completed. Now, the reaction is completed in the bucket also. Here we added more amount of water, so we got a suspension of calcium hydroxide or slaked lime. This is a suspension of calcium hydroxide, and this reaction is mainly used by painters to whitewash the walls. See, this is a recently plastered wall. Before painting this wall, we can apply a coat of calcium hydroxide on it. So a suspension of calcium hydroxide is already there. This is called a whitewash. Since I don't have a painting brush, I am using a coconut husk to apply the whitewash on the walls. Now what's happening? Another chemical reaction is taking place. The calcium hydroxide, that is a whitewash that applied on the walls, will react slowly with carbon dioxide in the atmosphere to form a white glossy finish of calcium carbonate. Water is also formed along with the calcium carbonate. So this will take some time. So the painters usually leave the walls for almost 1 week so that the reaction will be completed. Now come back. How can we express this reaction in the form of a chemical equation? That means not a word equation, using symbols and formulas. For that, we need to know how to write the chemical formula of calcium oxide. Calcium, the symbol of calcium, that is Ca, and oxygen, capital O. Now, The valency of calcium is 2. It is a group 2 element. So all the elements in group 2 like magnesium, calcium, barium, etc. Have a valency 2. What is the valency of oxygen? We have discussed it earlier. The valency of oxygen is 2 because it has 6 electrons in the valence shell. It needs 2 more electrons. So the valency of oxygen is 2. Now see, both are same numbers. The simplest ratio is 1:1. So the formula of calcium oxide is CaO. Now what is our next reactant? That is water. H2O. Please write the formula of water correctly. Okay? That is H2O. Now about slaked lime. Slaked lime is calcium hydroxide. So calcium, as you know, the symbol is Ca. Now hydroxide is a polyatomic radical having a minus charge. So the symbol is OH. Okay? Now the charge of hydroxide radical is -1. In order to write the chemical formula, we need to write only the charge. See, the number is enough. Now calcium, as we have seen earlier, it is 2. The valence of calcium is 2. Now crossover. There is 1 calcium and 2 OH radicals. How will you write it? Since this is a polyatomic radical and we need 2 of it, what you have to do is put the hydroxide radical inside a bracket. Then put the subscript 2 outside the bracket. Okay? This is how we need to write the formula of calcium hydroxide. Now, as you see, this reaction is highly exothermic. A large amount of heat energy is released in this process. Okay? So, we can also write heat. Here, put a plus sign here. And you can also write heat here. Now our chemical equation is complete. Remember, we are not adding any heat energy. We are simply adding water to calcium oxide. And in this reaction, a single product is found. But a large amount of heat energy is also released as a result of this reaction. Most of the combination reactions are exothermic. So this reaction is an example for a combination as well as an exothermic reactions. So this is a combination as well as exothermic. Children, please try to understand the difference between combination and exothermic reactions. Combination means a single product is formed when 2 or more reactants combine with each other. Now, exothermic means energy is released in the form of heat. Okay, chemical reactions or any process which involves the evolution of heat energy along with the formation of products. Such reactions are known as exothermic reactions. Hope you understood? Okay, now let's see. We have seen whitewashing the walls using calcium hydroxide. So, what will happen when calcium hydroxide is applied to the walls? You know, calcium hydroxide will slowly react with another invisible reactant in the air, that is carbon dioxide gas. Okay, so calcium hydroxide reacts with carbon dioxide gas in the air to form a carbonate salt of calcium. Calcium hydroxide reacts with the carbon dioxide in air to form a carbonate salt of calcium, that is calcium carbonate. Plus another reactant is also formed, that is water. Water will evaporate into the atmosphere and calcium carbonate will form a glossy white finish on the walls. So the painters usually leave the whitewash the walls for 2-3 days or for 1 week till the reaction is complete. This is a very slow reaction. But remember, this is not a combination reaction. This is kind of neutralization reaction, acid-base reaction. It is because calcium hydroxide is a base and carbon dioxide gas is acidic. Carbon is a non-metal. Oxides of non-metals are acidic, considered as acidic. So, a salt and water is formed. Children, I hope you enjoyed this video. Please like and subscribe to our channel. And please don't forget to press the bell icon for further notifications. See you.